we want to pay attention to. It's Dean and Mike from the team. So you're in good hands here. All of you guys do.
Cool. Yeah, nice to meet you, all you guys. And yeah, like you mentioned, I'm Mike. This is Dean from Tavily. Got a little mixed up here. And yeah, we're happy you guys all showed out.
We're building these applications with models, but they have a knowledge cutoff. And there's so much, like the world is dynamic. Things are happening every day. The models need to be aware of what's going on in the world. Us as human agents operating in the world, we like constantly seeing notifications, reading articles. So this real-time information is embedded in our brains. But for the agents that don't have web access, that's not the case. They're lacking so much context. So we believe that this web connectivity is an essential component of every AI agent, or maybe not every, but a very large percentage of that. So that's what we do.
Yeah, So like Dean mentioned, I guess what we focus on in Tavily is building what we call the web infrastructure layer for AI agents. So anything that an agent might require via interfacing from the web, that's what we want to offer. So we offer 4 key endpoints. We're an API as a service. So when you're building your agentic workflows, you would use us as a tool if you're building a React agent, or you can design your own custom deterministic nodes using Tavily as well. So our 4 endpoints are search, extract, crawl, and map, and they're kind of very interoperable. So search is probably what everyone's most familiar with. Provide a natural language query, get search results with context, so you can feed that context into your LLM to operate on the most up-to-date information. Extract is similar. It can be used with search, but you provide URLs, you get the extracted raw content, and then same deal, use that extracted raw content in your agentic workflow. Crawl and map are our 2 beta endpoints, so they've been released fairly recently and are launching officially in the coming weeks. I'm not sure if anyone's familiar with web crawlers, but the concept is you provide a base URL, like a root node to start from, and then we'll build this kind of graphical representation of a site. And for each node in the graph, which are like sublinks, we can extract the raw content, same sort of deal. Kind of generally, our goal is to provide this context, like Dean was mentioning, to your agent to be able to act on the most up-to-date information. Whatever you might be building, however you might want to interface with the web, we kind of provide these endpoints as like versatile tools to build whatever workflow you're looking to build.
And a good analogy, so over the last 20 or so years, we've kind of learned how to effectively find information on the internet. Begin by searching in Google, and you get a bunch of results. Then you find one that you think is compelling based on maybe the link and the title, and you click it and you start to read. So that first step of searching is like our search API. When you click the link and read all the contents, that's extract API. And then when you're reading that article, you might find nested links within it, and you kind of go down this rabbit hole of exploring deeper. That's crawling or mapping. So the way we have learned how to use the web effectively over 20 years, now we're entering this new era where we need to teach language models how to do the same thing so that they can autonomously discover information. We provide these atomic functions for what you can do on the web: search, extract, crawl, and map. And when you combine them with a language model and teach a language model how to use them in combination or in sequence, then you can really discover pretty much anything on the web and combine it with maybe your internal knowledge source or anything. So we're providing maximum developer customizability. That's kind of our philosophy.
Yeah. I guess maybe a general poll of the group. Like, does anyone, before we move on to like maybe some demos and some stuff that we've built to kind of showcase our tools, does anyone have any like initial questions on like stuff that we've talked about, or before like diving in, and we can kind of show you guys how you might build with Tavily in your own applications? whether it's stuff you're doing today or stuff you're doing in the future. Yeah. So map is kind of like the foundation of crawl, and so it's the same input for as for crawl. You start with this base URL, and we'll provide back like an array of sitemap of like starting at that base URL. So where map is specifically useful is the issue with crawl is that you get a whole bunch of context back. And so you can imagine, starting at, openai.com, they might have hundreds of thousands of nested URLs within openai.com, privacy on all of their products and like all this stuff. And for every site, it's kind of a similar issue. So when people are building agentic applications, they oftentimes want to filter out and decide which URLs that they get from the sitemap that they want to extract that kind of fit the needs of their system. So a typical, I guess, workflow that you might see is you'll first map from a root URL, find all of these links, and then do some post-processing on those links, determine which ones are relevant, and then extract the raw content from those. It also like saves on credits as well. With crawling, you might get like, thousands of URLs back, and for each of those URLs, we've extracted the content. And then if you're going to feed that into your LLM, it's a lot of tokens, and it's kind of a verbose way of a verbose approach. Whereas using map, you can kind of filter out, find exactly what you might want to look for, and then call extract on each of those URLs in some sort of batch processing way, get that information, and then feed that into the LLM. So it's kind of like an efficient way to, I guess, limit how many tokens you're providing to the LLM, be cost efficient, and yeah, that's kind of it. Yeah, so there's a few different competitors. I'd kind of group them into two different categories. One is like answer engines. So that's web search provided by like OpenAI or Perplexity, stuff like that. Anthropic as well, they have their own web search. And the common difference between those answer engines and us is we're a tool that can be used agnostically in your own implementation. We're not attached to a model. You can use it with Gemini. You can use it with Anthropic models, whatever you so choose. And answer engines, they provide an answer to your query with the key citations noted. Although we offer answer generation as part of our search API, it's an option for you. What we really want to provide you is all of the context from your search result and allow the developer to use those search results or the raw content that you may have extracted, crawled, whatever it might be, and use that in your system however you might want to use it, whether it's generating an answer based on that context, pairing it with your own internal RAG, like your internal knowledge base as well, and then generate an answer. There's a whole bunch of different ways that you can use it, but we're not tied to like, we don't just provide the answer with references. We provide the references and let the developer determine how they choose to use it.
And one thing I would add is maybe you want to search the web, but not use any language model after. Maybe you want to search the web, extract certain information, populate a database. So with Perplexity, OpenAI, Claude, with web, Gemini, you're guaranteed a LLM response grounded in web. That's
So the first category was answer agents?
Yeah.
The second one?
The second category is companies who offer similar stuff to what we offer. So, API as a service for different like web interaction, I guess, interfacing. And I think what we kind of do best is we focus a lot on our performance. We think that we're a top tier performer in the space, and that's why we recommend it to developers. Not to say that the other providers aren't also, solid as well. We think we perform better.
Yeah, and there are benchmarks published online. A common benchmark is simple QA. It kind of like evaluates your ability to answer questions grounded in real information from the web, and we're state of the art on simple QA. The reason why our quality is better is because we've developed, like, our secret sauce is a smart caching system that kind of promotes, we enhance the quality on things that are searched commonly, but certain web pages on the internet are almost never searched. We focus less on those. So we devote more compute and more processing on things that are commonly visited and less compute on things that are almost never. So what we get is with more scale, as more people use our product, and they tell us, they provide the signal to us what is relevant in the web, then we focus more on that. So that's how we're able to provide the highest quality search.
Any other questions before we dive into some use cases? Yeah, sorry, at the back there.
Can you tell me, is it almost like a 10th grader?
Yeah, sure. Are you have you graduated from 10th grade? Okay, great. Yeah, so I guess it might be a difficult thing to communicate to a 10th grader who maybe hasn't interacted with LLMs so much. But from my perspective, and I'm sure many of your perspectives on your first interaction with LLMs, you kind of realize what the capabilities are, and where that knowledge cutoff point is. So, in your first use of ChatGPT or Gemini or Claude, you might ask a question like, what happened yesterday, or what happened in the Blue Jays game yesterday? And it commonly would hallucinate. Obviously, things have advanced with new web search tools built into those systems. Initially, that was a huge problem that people faced, was that you're asking someone a question who doesn't know the answer to that question, but has to give you a response. So if you ask me what happened in the Blue Jays game last night, and I had no idea what happened, but I had to give you an answer, naturally, I'm going to give you the wrong answer to that question. I'll just make something up. Say we won 5-3 against the Red Sox. I have no idea. So our kind of whole goal is to bridge that gap between these LLMs, which have a clear knowledge cutoff point, and provide them with the context with which they can then use to generate accurate responses. Does that answer your question? So, like, from the simplest kind of description, and what I would say to a 10th grader is you can imagine Tavily as just this, source of knowledge that you're going to ask a question to and then get back the resources with which to answer. So it's like similar to, like, if you're studying for a test in high school or in university or something like that, you're going to read through your textbooks, you're going to find the answers and then use them to, like, recite when you're answering the questions on the test. So we're like, I guess, the textbook in that scenario, where we have all the knowledge. We're going to provide it to you based on your question. And then when you're going to write your test, or when the LLM is going to answer your question, your query, it's equipped to answer the question properly. Make sense? Cool.
Application website, can Tavily use those credentials to go in and extract information from that?
So no, currently we only support publicly available information. Something that our customers have requested quite a bit. If they have, for protected or private data, that's something that we're working towards. Currently we don't. Yeah, so we obey robots.txt rules. And just recently, like, Cloudflare published a blog post announcing kind of like a shift in this space, because with the advent of all these web crawlers, a lot of companies actually might want their agents to be crawled. They just want to be compensated for it. So there's like an emerging model on how that can be done, which is great for us because we can provide a better quality service and fairly compensate people who want their web to be crawled, their page to be crawled, as opposed to now we just won't crawl it and they won't be compensated. So the law is evolving.
Yeah, cool.
So is Google a competitor then? Or can Google also offer the same features?
Yeah, so that's a common question that we get. Google has an API that returns search results as well. And I guess the key difference between us and Google as an API is that Google only returns like small content snippets. We're talking like maybe a sentence long. So and I'm sure you guys have all seen that when you search in a query on Google, you see those little content snippets below each search result that might, like, give you the first couple sentences on the website. Oftentimes it's the header or something like that. So what our goal is, like, from our product offering, is to provide context to the LLMs, and in almost all cases, those short content snippets aren't sufficient for an LLM to actually determine what the answer is to the question. In some cases it might work, but I think you'll find, and a lot of our customers have found, that there's like a missing link. They're looking for a lot of raw content from every website. So if it's like a weather thing, then it might be all of the weather, or like a 7-day forecast or whatever it is. If it's reading an article on the latest happenings in the tech space or something like that, the information that the LLM needs to act on the question is almost always found in the long context of the website, not just in that short content snippet. So that's kind of what we provide, is all the context from the website rather than just that short snippet. And further to that, if you don't want to ingest all of the raw content of the website, let's say you're focused on minimizing tokens, we also provide a summary of each search results content as well that oftentimes captures the content from the website effectively, but in a shorter format. So that's, I guess, the key differences between us and them. And as well, like Google is one search provider. There are many search providers that we kind of use wholeheartedly, re-ranking the search results as well to provide the user or the agent with the most accurate search results for their task. Whereas Google obviously is just using Google search as their engine. Yeah, we'll just move on. Yeah, go for it.
Each AI lab fine tunes their model to behave slightly differently. I think this is something they've worked on, is to just say, I don't know. But yeah, this is like a very scientific question that I'm not really able to answer, but that like there's many different fine tuning approaches like reinforcement learning through human feedback where we'll try and tell the model when to say, I don't know, but ultimately it's like probabilistic, so you don't have full control over what it will do.
So basically, when the confidence is very low, you just say that.
Yeah.
Cool. Yeah, I mean, I guess we can little poll of the group, little raise of hands. Have any of you guys like signed in or signed up with Tavily today? Couple of hands. So you might have seen our API playground. This is kind of where a lot of our customers start off with seeing what our product looks like. And hopefully we've done a good job of explaining so far. And yeah, you kind of might have a general idea as to what we do. But you can see here on the screen behind me, this is our search API. So you can see that the required field is a query. So alluding to my question before, sure. You guys see that a little bit better? Yeah, so I'm typing in what happened in the Blue Jays game this weekend. So we'll search, and then we get these responses. So you can see what the response format looks like on the right side there. Effectively, it's an array of objects. For those familiar with developer lingo, where you have the URL the search result that we found with the title, and then you can see the short content snippet that we respond with, the summary of the search results. And yeah, like I had mentioned before, we have like a lot of versatility with our search API. All of these different fields that you can see there where my cursor is here are just different parameters that you can include in your search request, including raw content is one of them. So that would be like extracting all raw content from the search results. You can see we have extract too, which takes in URLs, and then crawling, which starts out at this root URL and builds that kind of site graph that we discussed. And then I guess we can show some of our use cases. So here is a common use case, which is embedding our search, extract, and crawl functionality into a chat application. I'm actually going to use a different key for this just to make sure we're all good. And we might ask what happened in the Jays game this weekend and hit enter. And then you can see that Tavily is searching. Eventually, we're going to complete the web search and then feed that kind of context into the LLM to generate this answer. Say this weekend, the Blue Jays played against the Yankees on July 2nd. This happened, that happened, etc. And you can kind of see these search results, where we're pulling that information from, the context that you're using as kind of reference to the answer that you're getting. And you'll notice there that the information is as up to date as possible, referring to games that happened this past weekend.
One thing I would add, so in this application here, so as we explained, we have the different tools, search, extract, and crawl. Our system will just autonomously pick which tool to use, depending on the intent of the user and the query. So for something like what happened in the Jays game, that's like a search type of query. But if we say like scrape this, if we provide as input a URL, which is known beforehand, they give us more information on this web page, then it will scrape the entire web page and provide a summary based on that.
What about multi-language? How do you treat that?
Yeah, so we support multilingual search.
So could I, for example,
So we provide a bunch of parameters or knobs that allow you to customize the search. One thing you could do is confine the search to a particular country domain, which we see our customers doing quite often. If they're based in one country, then they only want results from the web from that country. And that's done quite easily. We actually refer to that in our documentation, exactly, which I could share after if you're interested.
So, for example, let's say that you want to search for laws. Typically, you want only within Canada, but you'll have French and English. How do you? So will you on the fly? Will you translate the English text to show up as French for me, or will it stay English and French, and I'll have to do the translation myself?
We're not going to provide like LLM generated response for you with our API. What we're going to do is provide the search results most similar to your query. So if your query is in French, the results you're going to get will be very likely from French web pages. Then you can bring your own model. We're model agnostic, so you bring any model you want. It could be fine-tuned particularly for French. You can generate a response using that model.
Yeah, sure. Any questions? Yeah, in the back there. Yeah, so one of the fields in our search APIs include images and include image descriptions as well. And so we'll respond back with images as well with, or in addition to AI generated descriptions of those images as well, which are useful for multimodal applications too. 429 I think is rate limit. Okay, well maybe we can touch base afterwards and hopefully get you through to the end goal. Yeah, cool. Yeah. Well, thank you guys so much for listening, and we'll be around for the rest of the day. So if you have any other questions, feel free to come up to us and ask. Hopefully you guys are building some cool applications with Tavily, and we're excited to see what you have to build and to offer. And yeah, we're here as a resource to you.